Lecture we are going to see something called implementation of graph, okay, using an adjacency list. Okay, you already knew about the this theory part. So graph can be represented with two methods, adjacency list and adjacency matrix. So one of the representation we are going to see. Why we need is all we had seen in the theory part, right? Now this is the implementation code. Okay, I will explain one by one. Okay, let's move to the main part, that is this part. Okay, this is where the actual program will start, right? Okay, now in this we can observe this is a graph. Okay, and this graph I have to store inside a memory, so I have to represent using a adjacency list, right? Now you can see how many number of vertices are there. 5, right? To store vertices we need an array of 5 elements, right? That is our theory says. So we have an array of 5 elements, and this is where we store the vertices, right? Now in this graph you can observe one thing, that 0 is adjacent to 1 and 1 is adjacent to 0, or you can say that 0 is connected to 1 or 1 is connected to 0, or 0 is related to 1 or 1 is related to 0, or 0 is neighbor of 1 or 1 is neighbor to 0. All these statements are same. Okay, so while teaching I may use different statements, but okay, you try to understand, right? So how can I represent this connection inside this adjacent list? So when 0 is connected to 1, so you go to the 0th element, okay, and draw one linked list and put this 1 here, okay, and 1 is connected to 0, then you go to 1, okay, and put the 0 here. That means 0 is connected to 1 or adjacent to 1 and 1 is adjacent to 0. Okay, that's why I'm naming the array name ADG. The ADG means adjacent. So this array stores the address of adjacent nodes. Okay, it stores the address of all the adjacent nodes, okay, to that particular vertices. Okay, that's why the name of this array is adjacent. That means ADJ store, right? Now what is the step 1? Initialize the adjacency list with empty, that means null. That means all this cell inside this array have to be filled with null. Okay, you have to initialize it with null, right? Now let's see how can you do it using a for loop, right? So here we had already mentioned that I at the beginning I equal to 0, then I is smaller than v. Okay, let me see what is v here. So I already mentioned v as a global. So global it is defined as 5, v equal to 5, right? So this v will become what? 5 now. This v is nothing but 5, right? Then I plus plus, then after that I plus plus. Okay, fine, that we will see. Then what is written? For loop will enter into this particular statement, and it is adjacent of I. What is I now? 0. So at that adjacent of 0 I will put null. So where is adjacent of 0? Adjacent of 0 is this part. Here I will put null, right? So I will put null here, right? Now after that what will happen? It will come to this statement, and after that it will again go to this statement, that is I plus plus. Then what is I plus plus? It will increment to 1 now, right? Then again it will check, is 1 smaller than 5? Yes, condition is true. Then adjacent of 1 is what? Null. Adjacent of I means I is what? Now 1. So adjacent of 1 will null. So what is adjacent of 1? Adjacent of 1 is this part, right? So here you will put null, right? After that what will happen? I think you understood the flow, right? Then it will come to this statement and I will go back to I plus plus. Then again I will be increment to 2. Then again it will check, is 2 smaller than 5? Yes. If condition is true, then it will get inside this statement and it will again adjoin, I mean adjacent of I. What is I now? 2. And that there it will initialize with null, right? So you can clearly see adjacent of 2 is this part. So you will make it null here, right? Like this it will keep on initializing all the elements with null, all the cell with null, right? Because it is I, at the end, what is the condition? I smaller than 5 means it will go up to 0 to 4, right? To 0 to 4 all the elements will be initialized by null. Now you might be wondering why I'm putting null, right? See this particular array, it's not a normal array. Okay, you can observe here, I had already declared, see, this is a array of pointers. Okay, so all the elements inside here contains an address, so it's a pointer variable. Okay, and if there is a pointer variables, inside a pointer variable you can initialize null. If it is a normal variable, it is not possible. Okay, so it is not this, every cell contains going to be contain address of its adjacent list. Okay, contains an address of its adjacent list. That means this cell is not a normal cell, it is a pointer variable. Okay, it contains going to contain a pointer, or it's going to contain address, so you can initialize null here, right? Okay, now coming to this step 2, what it is written is add edge 0 and 1, right? You are going to add edges to the graph. So in graphically, what is the meaning of it? That you are going between 0 and 1 vertices, you are going to put an edge. Okay, that is the meaning of it. But in graphical, this is what in this meaning defines in graphics, in graph. But you have to represent inside a memory, right? Now in memory, what is the meaning of it? 0 and 1, if I write like this, then that means 0 is related to 1 or adjacent to 1, and 1 is adjacent to 0. You can clearly see, right? So in adjacency list, how you will represent? I will take one array and I will put 0, and 0 is adjacent to 1. So for 1 I will make one list, while linked list, and for 1, and I have to do for the 1 vertices also, for 1 who is adjacent 0, right? So I will, for 0 I will make one list and I will put adjacent to the 1, right? This is how you represent add edge, means 0 adjacent to 1 and 1 adjacent to 0. This particular graphical representation, okay, I will represent using an adjacency list in this way. Okay, so this is how in memory it will be stored, and this is how we human being understand. Okay, this is how computer will understand the adjacent. Okay, that 0 is connected to 1, 1 is connected to 0, and this is how that we human beings will understand. Then there is a connection between 0 and 1, or there is an edge between 0 and 1. Okay. Okay, now when you call, okay, we were here, right? So when we try to call this particular function, right, then this function is defined here, right? You can see this function is defined here completely, right? So what we are calling is, we are calling add edge, right? Add edge 0 and 1, right? That means for u is 0, and v is 1 here. That means this is 0 and this is 1 now, right? Now when you completely execute this function, right, what will happen? This is what will happen. This is how the particular means adjacency list will look like, right, when you complete this entire function. Okay, and you can clearly see here at step 1 I mentioned that add v to the adjacency list of u, right? That means when I execute this particular code, okay, this particular statements, then of step 1, then what will happen? There is a u, right? This particular state, this 0 is there, right? So u is 0, right? So for this particular 0, whatever the adjacent list is, I will create here. Okay, that is what will happen when you execute this particular code. And when you execute this particular code, then there is a 1 here, okay, and whoever the adjacent list for that particular 1 vertices, that will be created here in the linked list. Okay, and when you complete entirely, this is what happen. Entire code, this will happen in the memory. This is how we will create a adjacency list one by one. Okay, so let's see how this code executes. Okay, we will try to dry run. Okay, right, let's see one by one. Okay, now at the beginning you will try to execute this code, and what this line will do is it will create a node containing a v. Okay, and this node is what? This is a function. New node is a function, so it will call this function, right? Okay, so what will happen when we try to execute this particular line? Okay, then this node v, okay, will be called. This is a calling function. A node containing a v will be created, and this new node is a function. It will call this particular function, and the parameter we passed is 1 because v equal to 1, right? Then it will call this particular malloc function, this particular function, and this is dynamically allocating a memory. So it will dynamically allocate a memory. Okay, right, and this memory will have some address, right? This memory will have some address. And what kind of memory is it? It is a struct node. And what kind of structure node? So let's see the structure of this node. Structure of node is defined here. So it contains data, and it contains a next pointer, right? A pointer variable, right? Now this malloc will return the address. What was the address? 100 will be returned to some temporary variable, which is a pointer variable. So a temp will be there, and it is a pointer variable, right? And it will get 100. Then it will point to this particular node, right? Then after that, what is written? Temp.data. What is temp.data? This part. Inside that you have to put v. What is v? 1. And temp.next. What is temp.next? This part. Temp.next is this part. So here you have to put null, right? After that, return temp. What is return temp? Temp is this part, 100 you have to return. So you have to return 100 where? 100 to the calling function. Where is the calling function? This 100 will be returned to calling function, that is here, and you will get 100, and this 100 will be given to a current pointer. Okay, that is to a pointer variable which is a current. So you will take one more pointer variable, okay, which is current, and it will get 100, right? And it will be point to this particular address, okay, particular node. This is what will happen when you execute only this particular line of code. Only this particular line of code, this much will happen, right? Now what is the next line? Next line is this part. Okay, current next. What is current next? Current next is this part, that is null, right? And adjoint of u is this part. Adjoint of u is 0, right? So whatever the value of adjoint of u is, what is adjoint of u? That means this part, that is null. That you have to put inside a current of next. What is current of next? Here, current of next is this. So this null you have to put inside this current of next, and it is already null. So again you will put null, right? That's it. That is this line means. Then next line is adjoint of u. Again adjoint of u is 0, right? This part. And current is what? Current is 100. So whatever the value of current is, you have to put inside a adjoint of u. So what is the value of current? Current is 100, and this you have to put in adjoint of u. That means 100 here. Okay, let's try to put that. So what you will do is you will put 100 here, right? Then what will happen when you put 100? Then this particular list will point to here, right? So I am going to draw it properly. Okay, so this is what will happen, right? So I am going to draw it properly. Okay, now after this line, this particular line, all this statement is executed. After this line is executed, this is what will happen inside the adjacency list. Okay, that means 0 is adjacent to 1. Okay, this is how you inserted the neighbors of 0 or adjacency list of 0. Right, now you will move to step 2. Right, so you have to add one more, right? One is adjacent to 0, right? That also you have to add, right? So this particular part will do this part, right? Let's see how it is going to do. Now you can clearly see in step 2, again I'm going to create one new node. Okay, so for new node, see there is a function defined here, right? We have already seen this function, so I'm not going to explain this function again and again. You just try to understand. Whenever I call new node, what will happen? A node containing a u will be created. That means one node will be created containing u. What is u? 0, right? And current will point to it, right? And temp will point to it. That's it. This is what you have to understand whenever this particular line of code is executed. That's it, right? So I'm going to do it directly. Okay, I'm not going to explain again and again this particular statement, because otherwise this video will be very lengthy. Okay, so try to understand. Okay, so whenever I call this function, one node will be created. So you can see one node will be created like this, right? After that, what is this node will look like this. So you can understand one node will be created. Okay, and of it will contains of data and next, and node of u. What is u? 0, right? So it will contain 0, and one temporary variable will be, and for example some address will be assigned, right? So what will happen when you create new node, right? Like this. See, one node will be created, right? And that node will contain a value of u. What is u? 0, right? And this node might have some address, right, which is 200, and this address will be like this similar way. It will be, this address will be stored inside some temporary variable. That means some temporary variable will be pointing to this particular address, right? Like 200. And there is one more pointer which is pointing to this particular location, that is current pointer. Right, and null is already assigned here. So just by writing this particular node, okay, this particular line, this is what happened. A new node is created, and always remember, whenever new node is created, this is what it looks like, always. Okay, because for that I had already defined the function, right? So I can't explain again and again. You try to understand. Okay, now what is the new node? Okay, it will return some address, right? Its own address, which is 200. This 200 will be passed to current. So this is what happened. You got 200 here, and after that current next. So what will be assigned to okay, so adjacent of v. What is adjacent of v? V is what? V is 1, right? So adjacent of v means this. So this part is null. So null is assigned to current of next. What is current of next? Current of next is this part. So you will again put null here. Okay, null is already there. Again you will rewrite with null. Now what is the next, this third line? This is current. What is current now? Current is 200, right? This 200 is assigned to adjacent of v. Where is adjacent of v? Adjacent of v is 1. Adjacent of 1. That means here you will assign 200. Okay, here you will write 200, right? So I will mention that. So you can clearly see I had rewritten all those things. So this is how your slowly your adjacent list will look like. Okay, so what I will do is, see, I am going to create here. Okay, I will build here slowly, and I will rewrite here everything, so that you can understand properly what I am doing it, right? Now whenever you can see you're going to call this function add edge 0 and 1, right? So what is the meaning of this? That means 0 is between 0 and 2 there is one edge, and in terms of adjacency list you have to create one 0 and 2 here, right? That means for 0 there should be one node, right, inserted, and for 2 there should be one node, that is 0, right? Now the thing is, you have to create one node. You have to insert one node inside a singly linked list. That is the meaning of it. This entire thing is going to be singly linked list, right? And that node will be 2. That means 0 is connected to 2, or 0 is adjacent to 2. That is the meaning of it, right? Now, what is the method you're going to use? So what I'm going to use is, every time whenever I'm going to insert a node in the singly linked list, I'm going to insert it from the beginning of the list. Okay, that method I'm going to use. So I will insert a node from the beginning. So what I will do is, see, observe here carefully. Okay, I will take this part. Suppose 1 is already here, right? Now it is already connected here, right? Now what I will do, I want to insert one more node. Okay, so what I will do, I will insert one new node, that is 2, right, like this. Then I will try to connect this particular part with this 2, right, and this 2 of next will connect to this part 1, and 1 at 1 next I will assign null. Are you getting it? So this is how I am going to insert a new node in the beginning, right? So whenever you want to insert a new node, you will insert from the beginning itself in that singly linked list. Okay, so this is the method I'm going to use in the entire list, okay, in this adjacency list. Okay, let's see. So what I'm going to do is, I'm going to call add edge, right, on 0 and 2, right? So u becomes 0 and v become 2. That u is 0, v is 2, right? So what will happen at the first step? You will add new node, right? New node v, this part, right? New node v, this part, right? So new node v means you will add one new node, okay, containing v. What is v? 2, right? Suppose there would be some address, that would be 300. Okay, that 300 will be passed to current. Okay, so current will get 300, and there would be already a temporary variable which will also pointing to this 300 node, right? Now what is the next step? Adjacent of u. What is adjacent of u? Adjacent of u is what? 0, right? So adjacent of 0 means this part, that means 100. So 100 will be passed to current of next. What is current of next? This part. So this will get 100. That means it will point to where? That is a question. Then 100. What is 100? 100th location is this. It is talking about this particular node. Then current of next will point to this node, right? Can you see? It is creating a list. It's like inserting in the beginning. Then this part is, this next line is current. What is current now? Current is 300. This 300 is passed to adjoint of u, adjacent of u. What is adjacent of u? That means 0. Adjacent of 0. What is adjacent of 0? This part, right? So there you are going to put 300. So I will replace with 300 now. Okay, I will do it properly. I will replace with 300 now. Then what will happen? This part will connect to here, right? And this link will be break. This link will be gone, right? Now if you rearrange it, you can clearly see. See, you can clearly see it is like inserting from the beginning. Okay, so I will rearrange it and I will show you. Okay, so I will try to rewrite it here in this particular linked list, okay, so that you can understand. Now you can clearly see after rewriting it, it will look like this. See, the new node 2 is placed here at the beginning of the list, linked list. Okay, now you can see what is the meaning of this 0. Okay, 0 is adjacent to 2. You can clearly see 0 is adjacent to 2 and 0 is adjacent to 1. That means 0 is adjacent to 1, right? So using this list you can clearly understand. Now 1 is adjacent to 1. Okay, sorry, here I think I done one mistake. 1 is adjacent to 0, I think, right? It is 0. Okay, right, now it is fine. So 1 is adjacent to 0. That's means 1 is adjacent to 0. Right. Now one more it's remaining, right? That is this part, step 2. Where it is? This part. So we will try to do this thing also. What is this? The statement is we are going to create an adjacency list from U to V, right? So here we are going to add a U to the adjacency list of V. So let's see what is V here. V is 2. Okay, fine. So we try to create that part also. Okay, so what does it mean is, see, we had already created 0 to 2. Okay, 0 is adjacent to 2. That connection we established, but from 2 to 0 is still remaining, right? So that is what this step 2 means, right? So we are going to establish, for 2 we are going to establish one node, that is 0 here. So let's see, for that this particular code is okay. So we will see that part. Okay, now when you try to execute this part, what will happen? One new node will be created. Okay, one new node will be created with containing U. What is U here? 0. So with 0, one new node will be created. Suppose its address is 100, right? And there would be a one temp variable which will point to this 400, and there would be a current pointer which will point to this 400, right? Now what is the next line? Adjacent of V. What is adjacent of V? Adjacent of V is 2. Adjacent of 2. So I am talking about this part. So what is adjacent of 2? Null. So null will be given to current of next. What is already null is there. When you create a node also you will get null. So what you are going to do is, we are again to replace null only. Okay, so again you will rewrite null. So here again you are putting null. Fine. Now next part is current. What is current here? Current is 400, right? You can see current is 400, right? And this 400 is assigned to adjacent of V. What is adjacent of V? Adjacent of 2. That means I'm talking about this part. So here I will put 400. Then what will happen? This will connect to this particular memory location, right? So you can see this is how adjacent list is created. Okay, so when you rewrite it, you can clearly see that 2 is connected to 0. That means 2 is adjacent to 0, right? So I will rewrite it again. Now next is, you will call add edge 1 and 2, right? So what will happen? You will get 1 and V will get 2. Okay, so U and V value is 2. Now all is same. Okay, now I'm not going to explain in a deep way. So everything is similar now. So there would be a new node created, okay, with V containing V. So I will going to create one new node containing V, right? So what is V? V is 2, right? I already mentioned here V is 2. Okay, there would be some address for this, right? And one current pointer. Okay, I'm mentioning it current pointer with C, right? So that is 500, right? That is 500, and temp variable with for example it is current, and temp also contain 500, right? So all these are variable, pointer variable. So whenever you create a new node with V, this is what happens. Now what is the next step? Okay, adjoint of U. What is current of next equal to adjoint of U? What is adjoint of U? Adjoint of U is 1. That means this part is 200. That means 200 is assigned to current of next. What is current of next? That is this part, 200, right? That means this next will point to 200 location. That means this location. Okay, this memory block. Then what is the next part? Current. What is current? Current is 500, right? Can you see? Current is 500. Then this 500 will be assigned to adjoint of U. What is adjoint of U? Adjoint of U is 1, means adjacent of 1, right? So you will assign 500 here. Then what will happen? See, this particular line will be gone, and this line will point to 500 location. Now you can see it is like inserting a linked list in the beginning of a singly linked list, inserting a node in the beginning of a singly list. You can see if you rewrite it, then it is a singly linked list, right? See. So this is how you will establish a connection, right? So that means one is adjacent to 2 and one is adjacent to 0. So you can see in the graph also, one is adjacent to 2, one is adjacent to 0, right? So you can see I had rewritten here completely, right? So we are done for adjacent of 1, right? Now for this next step, right? For adjacent of 2 also we have to do it, right? For 2, for 1 we have done it, for 2 also we have to do it, right? So 1 is adjacent to 2, then 2 is also adjacent to 1. So that also we have to mention in adjacent of 1. So here you can add adjacent of 2, right? At adjacent of 2 we had already mentioned on about 0. So for 1 also we have to mention. So for 1 what you will do? Again you will insert a new node 1 at the beginning of the singly linked list. So here itself you will add one new node 1 and you will try to connect it. Okay. So for that this code is. So we will see that part, right? So here it is written, we will add new, we will create new node u. What is new? It is mentioned 1, right? So I will create new node new, and as usual current will contain 600, okay, and temp will contain 600, right? So both are pointers, it will point here. Now what is the next line? It's adjacent of v. What is adjacent of v? V is 2, right? So adjacent of v means 2. I'm talking about this part. So it contains 400, right? It is passed to current of next. What is current of next? This part. So 400 is given to here. So what is 400? This part. So this will point to this particular location 400. Its next will point to this particular location 400, right? And next line is current. What is current? 600. 600 is given to adjacent of v. Okay, what is adjacent of v? Adjacent of v is this part. V is 2, right? So here you will replace it with 600. That means I will replace it with 600. Then this connection is gone, right? And you will establish a new connection that is 600 with this particular 600. Now you can clearly see that one linked list is created, right? So you can see this is how your connection is established. That means 2 is adjacent to 1 and 2 is adjacent to 0, right? So I think, hope you're understanding. This is how the adjacency list will be created. Okay, so we are already seen till this part, right? Okay, now we will see add edge 2 and 3. Means between 2 and 3 there is an edge we have to add, right? So we are already seen how to construct this adjacency list, okay, using this function add edge. Okay, we have seen that part. Okay, now I don't want to explain. I think you understood that flow, how this code is working. Okay, that was my intention, okay, so that you can understand. So what I am going to do is I am going to directly add this particular add in this adjacency list, and I will fill this adjacency list, right? So let's see what is this particular add 2 and 3. So add 2 and 3 means you have u equal to 2 and v equal to 3, right? Now what you have to do is 2 is at what is the meaning of this 2 and 3? That means 2 is adjacent to 3. So I have to add 3 somewhere, where at wherever the 2 vertices is at. So here itself I have to add 3. So here at 2 vertices I have to add 3 in the beginning, right? That's it. So how can I add it? I have to remove all those things, right? So that means I have to add one node here. So I am going to add one node here, right? And this node will contain a data what? 2 is adjacent to 3, so the data will be 3. Suppose the address is 700, right? Now inside this particular node next, what would be the what would be the address? The address of this next node, that is 600, right? Then it will point to this particular node, right? Then here at adjacent of 2 you will update with 700, then it will point to this particular address. So this is how you insert a new node in the linked list. Okay, now you can clearly see 2 is adjacent to 3, right? 2 is adjacent to 3. Now this also means that 3 is adjacent to 2. That also you have to mention, right? So for that also you will create one more node. Okay, you will create one more node. Okay, suppose that address of that node is 800 and the value will be 2, right? Because 3 is adjacent to 2, right? And at the beginning it will be null, right? And this adjacent of 3 will contain address of this node, that is 800. Then it will point to this particular node, right? So this is how, when you execute, try to execute add edge, this is what will happen, right? Now we will see add 3 4. The next function is add 3 4. Then what will happen? Let's see. Okay, so 3 and 4, right? So your u will be 3 and v will be 4, right? So 3 and 4 means first 3 is related to 4. So you have to create a adjacent node here. 3 is connected to 4, 3 is adjacent to 4. So you have to create one node here and at the beginning of the linked list, right? So let's see, we are going to build that thing. Okay, so at the beginning I have to create one node, right? And what would be the data of that node? 3 is related to 4, 3 is adjacent to 4, that means the data would be 4 here, right? Suppose the address of that node is 900, right? Now its next, this particular node next will contain 800, then it will automatically point to this particular node, and here the adjacent of 3 will contain 900 now, then it will point to this particular node. Okay, so this is how you are inserting the new node in the beginning of the linked list. Now you can clearly see 3 is related to 4, right? This particular property is holding now, right? That means 3 is adjacent to 4. Now if you are writing 3 4, then 4 is also adjacent to 3, right? So for that what you have to do? You have to create one more node, right? And suppose the address of that node is 1000, right? Then what would be the value? Value will be 3, right? Because 4 is adjacent to 3, and at the beginning the node next will be null, right? And here adjacent of 4 will be updated with the address of this node, that is 1000, then it will point to this particular node, that is 1000, right? So by writing this add 3 4, this will happen, right? Now we will see add edge 40. This is the last one, so we will understand what will happen here, right? Now what will happen here now? Let's see. We will get one more node, 4 0, right? So u will be 4 here and v will be 0 here, right? Now 4 0 means 4 should be adjacent to 0. That means at the beginning, here at the beginning there should be one node 0 and it should point to the 3. So we will try to do that part. Okay, so in the beginning I will add one node, okay, and 4 is adjacent to 0, so 0 will be there, and nodes next, okay, that means see there would be one pointer current, okay, remember this point. So current next, that is how the code is written, okay. So but I don't want to get into the code, we have already seen that code part. I am directly completing this adjacency list, okay, so that you can understand. Okay, hope you understood the coding part, okay. This I am just completing it. Now current next, that means the current next will be filled with 1000, so it will be automatically point to this particular node. And here suppose the address of this part will be 1001, then it will be updated with 1001, then it will point to this particular address, right. Now this is what happened. Now 4 is related to 0, then 0 is also related to 4, right. So this part you have to update it. So where is 0? Here. So here you have to insert 4. Are you getting it? So you have to insert one node here in the beginning of the linked list, which will say that 0 is related to 4. Okay, so we will do that part. So I am inserting one new node. Okay, and suppose its address will be 1002, right. And what would be the value? 0 is related to 4, so value will be 4. And that node means that this node will be current, right. This current next will be what? 300. It will be filled with 300, then it will automatically point to this particular node, right. And this part will be what? Means adjacent of 0 will be 1002, then it will point to this particular node, right. So now you can clearly see that 0 is adjacent to 4, 0 is adjacent to 2, 0 is adjacent to 1. So this is how we will complete our adjacency list completely, right. Now if you want, you can verify this particular adjacent list is right or not with this graph also. So you can see 0 is adjacent to 4, 2 and 1. So look at this graph. 0 is adjacent to 4, 2 and 1. Yeah, this is true. Now 1 is adjacent to 2 and 0. So 1, where is 1? 1 is adjacent to 2 and 0. Yes, it is valid. Now 2 is adjacent to 3, 4 and 0. 3, 1 and 0, sorry. So 2, where is 2? 2 is adjacent to 3, then 1, then 0. Okay, so that is valid. Now 3 is adjacent to 4 and 2. Where is 3? 3 is adjacent to 2 and 4, or 4 and 2, right? Both are valid. Now 4 is adjacent to 0 and 3. So where is 4? 4 is adjacent to 0 and 3. Yes, so this adjacency list is perfect. Okay, so hope you understood how to create a adjacency list using a graph. Okay, so this is the code, and first you have to understand the flow of the code. Okay, and once you understand, it would be very easy. Okay, so please go through this video again and again, then only you will be able to understand it. In first go you might not able to understand it. Okay, and before understanding this particular code, you should be very good with array pointer, linked list, okay, and few basic about graph theory. Then only you will able to understand this particular topic, okay, and this concept of, and this code also, right. Otherwise you will definitely face some problem. Okay, fine. Okay, now the next step is print, right? Step 3, that means you have to print this graph. Graph means this particular adjacency list you have to print in the console, right? How you going to do? See how the print will look like. See, you can see here. So at the beginning there would be 1 0 here, right? That means 0th vertex, and you can clearly see for 0th vertex who are adjacent 4, 2, 1, right? So it will be printing like this, 0 colon, then after that 4, 2, 1, right? Then after that it will come to this particular vertex for 1 who is adjacent 2 and 0. So it will print like this for 1, 2 and 0. And similarly for 2, 3, 1, 0. So it will print like this for 2, 3, 1, 0. So on. So like this print function will print this particular adjacency list, right? Let's see. For this print graph, I had already mentioned the code here. Okay, you can see here, this is the coding. Okay, this is the coding part for the printing the graph. So you can clearly see there is something called I equal to 0 at the beginning. Okay, this is for traversing the vertices. Okay, so what I am going to do is, at the beginning I is equal to 0, right? Then V, what is V? V is 5, right? We already knew that because it is globally declared, V equal to 5, right? Now print I. So what is I? I0. So it will print like this, 0, and you can observe there is one colon here, right? So it will print this I colon, right? So it will print like this. Then after that, traverse the linked list of that vertex. Now that means you already printed the 0, right? Now after that you have to print 4 to 1. You have to print 4 to 1. How can you do it? For that, easy method is what? You will take one temporary variable, okay, pointer variable, and it will point to 1002, right? And after that it will print 4, and then you will increment temp variable and it will print 2, then it will increment temp variable and it will print 1. Okay, like this you will traverse the entire linked list and you will print one by one. Okay, this is how you are going to do it. Okay, let's see. In the code also same thing is written. So it is written temp will point where the adjacent of I is pointing. What is adjacent of I here? Adjacent of I is what? 0. So adjacent of 0 is what? Adjacent of 0 is this, means I am talking about 1002. So temp will contain, so this part will contain 1002 and this will be passed to temp. That means there is one variable called temp, right? And it contains 1002. That means it will point here now. This is what it happened, right? Now after that you will check whether temp is not null. Yes, temp is not null using a while loop. Temp is pointing to something, right? Temp contains some value, that is 1002. And then it will come to this point, print temp of data. What is temp of data? 4. So it will print 4 now. Then temp equal to temp next, right? Then that means what is temp next? Temp next is 300, right? Temp next is 300 and 300 will be passed to temp, right? So this time what will happen? Temp will get 300. That means now temp will point to here at 300, right? Then again while loop will come and it will again check, is a temp not equal to null? No, temp is not null, temp is pointing to something. Then temp of data, what is temp of data? 2. Yes, it will print 2. Then again same thing, what will happen? Temp equal to temp next. Okay, so temp will contain temp of next. What is temp of next? 100. So it will contain 100 now. Then what will happen? Temp will point to 100 now. Right. Now again this while loop will work. Again it will check. Is temp null? No, temp is not null. Right. Then it will again print temp of data. What is temp of data? That is 1. Then again temp of next. What is temp of next? Temp of next this time is what? Temp of next is null this time. Right. So temp of next is null and it will be stored inside a temp. So you will get null now. So now temp is pointing to null. Right. Now again the while loop will come and it will check, is temp not equal to null? No, this time temp is null. So it will come out of the while loop and it will print, okay, new line. That's it. So print new line means it will go to new line. Okay, it will come to new line. So that you can start from here now, whatever the printing is. Right. Okay, now you can see the control will come to this part and this is the curly brace of for loop, right? For loop is still working, right? This is a control loop. Then control will go to I for loop, then I will be incremented, right? So I will be incremented to 1 then again the same procedure will work, right? So now we will see that. Okay, now this time I will be incremented and it become 1. Now is 1 smaller than 5? Yes, condition is true. Then it will come to this statement, and what it will be print? I. What is I now? 1. So it will print 1 now, right? Then again it will traverse. It will make one temp pointer at adjacent of I. What is adjacent of I now? Adjacent of I is, what is I now? I is 1, right? So adjacent of I is adjacent of 1. What is adjacent of 1? This part I am talking, means 500. That means your temporary variable, okay, will contain 500 now. Okay, that means it will point to 500 now. Okay, so I think this code is same only. Okay, the same way we have done it, we are going to do it here also. Now again it will check temp of data. What is temp of data? 2, right? Wherever temp is pointing, it will point is data. Then temp of next, that means temp will point to, that means temp will be incremented. Temp of next will be this part, right? Then again it will go to while loop and it will check, is temp is null? No, temp is pointing to something. Then again it will print temp of data, that means 0. Then it will print temp of data, that is 0. Then again it will increment temp of next. What is temp of next? Temp of next is null. So this time temp will get null, right? Temp will get null, right? Then again loop will go here, right? And it will check, is temp is null? Temp is not equal to null? No, this time temp is null, right? Then it will again come back to this particular line. It will again come back to this line, that is print line. Then you will move to the new line, right? Then again after new line it will again go back to the for loop. Okay, it will again go back to the for loop, and what will happen? This I will be incremented. I will increment it to 2. Then again the same procedure will happen. Okay, so then again the same thing will happen, right? Then it will check 2 is smaller than 5. Yes, condition is true. Then it will write yes, 2 is smaller than 5. Then again it will print 2, right? Then again it will check. Okay, then it will take whatever the value of 2 is, that is 700, right? So adjacent of 2 is what? 700, right? So it will take that value and it will place inside a temp. So again one temporary variable will be there, that is here. Temp will be pointing it at particular value, right? Because it is 700. So 700 will be given to temp. Now again using this temp we will keep on printing the value, that is temp of data, then next temp of next, and then again its data. Like this you will keep on traversing this entire list using this temp, and you will print this data 3, 1 and 0, right? Like this again for loop will be incremented. Okay, and this time what will happen? It will be okay, this time for loop will be incremented, and this time it will be 3, right? Again it will check, is 3 smaller than 5? Yes, condition is true. Again it will be printed 3. Then after that adjacent of, what is this? Adjacent of I means adjacent of I means adjacent of 3. What is adjacent of 3? Adjacent of 3 is 900, right? So you will place 900 inside the temp. That means temp will be pointing here this time. Now temp will traverse the entire list and it will print 4, 2. So it will print 4 and 2, right? The next time now again for loop will be incremented, right? Okay, now for loop will be incremented, that means I will be incremented to 4, and again it will check, is I 4 smaller than 5? Yes, condition true. Then it will print 5. So here itself it will print it will print 4, right? Print I means I is what? 4 now. Then again it will do the same thing. Okay, adjacent of I, that means adjacent of 4. What is adjacent of 4? Means I am talking about this particular part, 1001. So 1001 will be given to temp. That means temp will be pointing here now, right? Then using this temp you will print this entire 0 and 3. So after that 0 and 3 will be printed, right? And after that again there will be new line. Okay, then again for loop will be incremented. Okay, now for loop will be incremented. Then this I will become 5. Right, now the condition will be checked. Is 5 smaller than 5? No, this condition is false. Then what will happen? It will come out of this for loop. Right, it will come out of this for loop, and after that it will come out of this function itself. Okay, then this calling function is over. Then after that you will return 0. So like this, meanwhile you had already printed the adjacency list. Right, so this is how this code works. Okay, so please go through this code. Okay, otherwise if you are not good with concept of linked list and traversing and everything, you will face many problems, because all this code is related to traversing of linked list, adding a new node at the beginning of the linked list. Okay, array pointer concept, all these things we are combined here in adjacent list. So when if you are not good with any of this topic, then definitely you will not understand many things from this particular topic. Okay, so it's better before watching this video you just revise all those concepts so that you can understand this topic very well. Okay, my intention was to understand so that you can understand the flow of this code. Okay, most of the topic and concept I had covered in the theoretical part. Okay, fine.